Hi everyone, welcome to the Bioinformatics Coach channel. In this video, I'm going to show you how to install bioinformatics tools using Singularity. Now, what is Singularity? Singularity is a software that allows you to generate containers. And so there is this page here which gives you a brief description of what Singularity is. Okay, I'll leave the link to this page in the description box. So basically, what happens is with Singularity, you're able to create containers. A container typically comprised of software that have been pieced together, different software that have been pieced together. And so this allows you to create a software environment that is portable. All right. Let's say, for example, you have your software installed on a particular platform. Now, if you change platforms, what typically happens is that you have to reinstall the tools again. Now, with Singularity, all that you have to do is to create your container. And if you are moving to a different platform, you just copy that container, which is a single file, and then you can now reuse that container with all your software already installed, so you don't need to reinstall the software again. Okay, so it makes things portable for you. Also, sometimes you may want to run specific versions of some tools, and so if you have everything in a container, then all I have to do is to just rerun that container and you have access to the same software versions. Okay, so that's what you need to take notice. So this also allows you to have what you call reproducible pipelines and workflows. All right, so that is in a nutshell what Singularity helps you to do. So let's proceed. So for this tutorial, if you want to follow it, you need to make sure you have Singularity installed, and I have a tutorial that shows you how to install Singularity. So check the description box, you'll find the link to that video. Okay, now with software installation, what we need to do is to create a container, and in the process of creating that container, we also include a software installation. All right, now there are different approaches. In this tutorial, I will discuss how to use the definition file, which is here. So on this page, all right, when you visit this page, the link to this page is in the description box. So when you visit this page, click on the definition file, and then you have the page showing up here. Okay, it's a pretty extensive document. What I want you to take from this page is the overview. All right, so with the definition files, you have the header and you also have sections. Now the header is mandatory. You need to specify information for the header, and then the sections optional, what you want you add, and etc. All right, so I have a simple definition file here which I'll use to explain further. So this is a simple definition file. All right, so the definition file, we have the header, which is line 1 and 2, and we have the sections, which is line 5 downwards. All right, so let's look at what this file is. So now let's look at the header. All right, so with the header, I start with line 1, which is bootstrap. This is mandatory. You have to start with the bootstrap. All right, now you are going to install software, and so obviously you are going to install in an operating system. All right, so what bootstrap tells Singularity to do is to look for a base operating system or a base image. Now we need to look for this image from a repository. Okay, and so what we have is that bootstrap tells we are looking for a base image from where? From Docker. All right, from the Docker hub. That's what it means. So we have bootstrap looking for a base operating system image from Docker hub. That's what we have here. There are others you can use in place of Docker. So just check the Singularity documentation and you'll find other options as well. Now let's look at line 2. We have from. We have our base image. Now which base image are we using? This is where the from comes in. So from, when you specify a name, that means that Singularity will go to Docker hub and look for the base image that has this name or this tag. That's what it simply means. So in other words, we are looking for a base image from Docker, and the base image we want is Ubuntu 22.04. All right, that's what it means. Now let's look at the posts. Now when we get our base image, we need to execute some commands to install the tools. Okay, so these commands come under the posts. All right, that's what it means here. So with the posts, we are dealing with an Ubuntu system, and so obviously apt-get will be used. Okay, this is what is used to update Ubuntu packages and also install tools. So first we issue the apt-get updates to update the system. Then we issue apt-get install to install our bioinformatics tools. Now we are starting with FastQC. I'll show you how to install other tools as well so that you have a feel of how to use Singularity. So apt-get can be used to install FastQC in Ubuntu. All right, so that is for this one. Now we will add something else. Okay, but for now, let's go to the terminal and then start the exercise. All right, so now I am on the terminal now. So what I'm going to do first is to do a cd. I'll cd to my home directory, so I'll say cd just to make sure I'm in my home directory. Then I'll create a project directory, so I'll say make dir Singularity. Okay, Singularity. Then I'll cd into it. Perfect. Now I'm going to create my definition file, which I showed earlier. I'm going to create this. All right, this is what I'm going to create. I'll add something else to it, so just stay tuned. Okay, so I'll say nano and I'll say fastqc.dev. Now take note that the definition file is just a text file with instructions that Singularity will use to build your container. Okay, so that's what it is. So you can use any text editor, VI, Nano, etc. I'm using Nano to edit and then create that file. So I'll open it and I'll start with bootstrap :space and I'll say docker. Next line from :space Ubuntu 22.04. 22.04. Now the next line, that's where we have the post. So it's shift 5, that's percentage symbol, posts. In the next line, I will give 4 spaces, 1, 2, 3, 4. And I'll say apt get -y updates. Next line, space, 4 of them, and I'll say apt get install -y FastQC. Now I'll add another option, which is the environment. So environment. Now the environment allows you to specify variables, okay, which we refer to them as environmental variables in Linux. Okay, now I'll explain what I'm going to add. So let me just add it first. So next line, space 1, 2, 3, 4, and I'll say Debian _ front end. You also need to specify it. So Debian front end equals non-interactive. Now this is very important, okay, to avoid a situation whereby in the process of building the image you will be asked for inputs. We want to avoid a situation whereby we are asked for input. Sometimes this can cause the process to hang. Okay, it can cause the process to hang. And so Debian front end equals non-interactive tells Singularity that we don't want any interaction. We want everything to flow without us having to specify any inputs or without the system asking us for any input. So that's why we are putting this there. All right, so take note of that. Now this is all. So we are going to exit, save changes, and then do an ls to see the file, and I'll do a cut just to see the content to make sure everything is fine. Then I'm going to build the image. So to build the image using Singularity, we say Singularity build, and I'll say --fake roots. Now if you are installing packages in Ubuntu, you need a root access, and so the fake root allows us to appear as if we are roots, or we have root access, and then we can install the packages using these commands. Okay, so that is what the fake root is for. Now I'll do a space and I'll add my output file. Now when you build a Singularity image, you generate the .sif file. This is a file, and so that means we need to have a name for that file. So I'll say fastqc.sif space, and finally we add our definition file the one we just created. So that will be fastqc.def. Now that we have this, ladies and gentlemen, let's build our container. So I'll execute this command, and then I'm going to wait for everything to get done for me. All right. So you will see some tests coming up. You will see some Ubuntu like activities going on, which is fine. So all that we have to do is to wait for everything to get done. So let's wait and see how it goes. All right, Singularity has completed its work. All right, so you are going to see this information here. The last one says build complete, fastqc.sif. So let's clear the screen. Let's do an ls. We are going to see this file here, the zip file. All right, you can also use your file manager to see it. There's a file. All right, now let's proceed. Now that we have this, we are going to test. We installed fastqc. All right, so we are going to run fastqc. Now with fastqc, if you were to run it on your normal system, let me just open something here. If you were to open it on your normal system, you can do something like this, fastqc-version, just to see the version. Now, because it's in a container, there's a different approach. All right, so this is the container. Okay, the Singularity container. So if you have to run a Singularity container, you have to specify some initial commands before adding the software commands themselves. So this is how we do it. We say Singularity exec. There are other approaches as well. This one works fine. So Singularity exec, and then you specify your .sif file, your zip file, this file here, fastqc.sif, the container. So I'll say fastqc.sif. Then you specify the tools, okay, the command of the tool that you want to use. So here I'm using this command here. So I'll say fastqc --version. I'll run it like this. Okay, so let's execute this command. Perfect. So if you do it like this, I want you to just look at this one here. This is a version. Okay, so here it gives me version 0.11.9. okay, now for this one here, okay, just ignore it. We don't need it. It's not necessary. So just ignore this. It's just a warning, okay, which will not affect whatever we want to do. So just ignore it. Okay, I'm sure there are ways to deal with it. So if I find a way, I will do a tutorial to show how to suppress this warning. Okay, but for now it's fine. You don't have to worry about that. Perfect, because fastqc has been specified here. The version has been specified, indicating that we have successfully installed fastqc. Now, how do we test? So since fastqc is a tool that is used for assessing the quality of raw reads, we are going to test by downloading an example data and then use that to test. So I'll go to this page. I'll show you this page here. So the link to this page is also in the description box. I repeat, the link to this page is in the description box. We are going to download some paired end reads and then run them. Okay, so when I come to this page, there is an E. coli genome. I have two files here. I'm going to download these files. So I'll start with this one. I'll right click and I'll copy the link address. I'll do it again, copy the link address, and then come and download here on my system. All right, so I'll download it first. I'll just do this. I'll do an ls again and I'll download. I'll say wget space and I'll specify the link to download it. Okay, so I'll download this first. Okay, it's a small file, so it will not take much time to download. Okay, so we are going to download this as well as its counterpart, which is the read 2, and then run a fastqc on all of them. So let's wait for this to get downloaded and then download the other one and then test with Singularity. All right, okay, read 1 is done. If we do an ls, you will see it there. Now let's download read 2. So I'll go back to the page and get read 2. So I'll right click and copy the link and then come back here and then download. So I will type wget and I'll paste the link there. All right, this is the read 2. Now let's execute this command. Perfect. This is also being done for us, so we'll just have to wait. All right, great. So let's wait, let's get this done. All right, the second file has also been downloaded. So let's look at them. I'll clear the screen, I'll do an ls. I'm going to see the FASTQ files. Okay, so I have read 1, read 2. Now I'm going to run FastQC. So if you were to run FastQC on your normal environment, you will do something like this: fastqc star.fastq.gz. All right, so again, you will maintain this command and then you add the one for executing the container. Okay, and so here what we are going to do is to say Singularity exec, just like we did, specify your .sif file, which is fastqc.sif. Then I'll say fastqc and I'll say star.fastq.gz. Let's run this command. Perfect. So now you can see that fastqc is analyzing. All right, so it's so cool if you run things in Singularity. Okay, it's analyzing and then it will generate a report for both read 1 and then read 2. All right, that's what we need to know here. So let's wait for everything to get done for us. Perfect. Now FastQC has done its work. Let's clear the screen. Let's do an ls and we are going to find the FastQC outputs, okay, which is very good. So with the outputs, I'll just open them. I have this and this. I'll open them with my browser. This is the first one. So this is it. Okay, this is the FastQC outputs. Okay, so here we see that the reads are okay, but we still have some reads here which have low quality. So these are the ends. This is luminal read. So this happening here, it's a typical characteristics of luminal reads. So this is for read 1. All right, now read 2, the report is here. You can also open that and also get it sorted out or read about it, read on it. Okay, so there's also another read. Okay, so this is what we have for FastQC. Okay, so we have installed the FastQC tool via Singularity. Okay, so this is what Singularity can do. Now aside this, you can install several tools as well at once. Okay, so this definition file, if you want to add additional tools, you can do that. Now let's try this. Let's just say we want to install FastQC and then Spades, the genome assembly Spades. Okay, it's possible to do that. So in that case, what I'll do is to make a copy. I'll make a copy of the fastqc.dev and I'll just say assembly, or let's say spades.dev. Okay, those will be the name for the tool that you want to add. Or if it's a pipeline, you can simply just use the pipeline. So let's just say it's a genome assembly pipeline. I can just say assembly.dev. I'll just make a copy and then I'll modify that copy. So I'll say nano assembly.dev and I'll put whatever tools I want. I made mention you can install more than one tool. So here, let's say we are installing 2 tools, FastQC and Spades. I'll just add them here like this. Everything else is okay. We will leave them as they are. Okay, some things are also for advanced users, but as a beginner, they should be fine, right? And I can do Control X, save the changes, do an ls to make sure the file is there. And then I'll now build Singularity. Okay, I'll build this container with Singularity. So I can say Singularity build --fake roots, and I'll say what assembly.sif, and I'll say assembly.dev. All right. You should also make sure that you go through your commands to make sure they are the right commands. Okay. So if I go back to the previous command, which was successful, it was something like this. Okay, so I'm using something similar. all right, which is here. So let's just go back to it. Okay, so that's what I have. So let's execute this command and install fastqc and spades. All right, the assembly.cif has also been built, that container. So I'll clear the screen, do an ls, and I'm going to see it here as well. This is it. Now, because this has fastqc and spades, I will run spades here. I will just do a test. So again, I can just say Singularity exec assembly.sif, and I will say spades.py, and I'll say minus version. Let's run this. Perfect. So this also gives me spades version. So we have version 3.1 installed. Spades also comes with an inbuilt dataset, so you can use that to do a test to see if Spades has been successfully installed. So you can do a genome assembly. Okay, so with this same command here, instead of dash version, I'll clear it and I'll see dash test. So this will perform a genome assembly for me. So let's do this. If you do it, you will see that it's doing some genome assembly stuffs. Okay, because Spades comes with some test data set that you can use to test to make sure that indeed Spades is working. Okay, so this is the power of Singularity. Okay, perfect. So it has been done. So if I do an ls, let's clear the screen first. If I look at the logs, it says everything is done successfully. Now if I do an ls, I'll see an output directory called spades test. So I can say ls spades test to see the contents. I have my scaffolds, I have my contigs. I can say cat space test contigs.faster to see, okay, all this here. All right, so these are things you can do. Now for the data sets we downloaded, you can also do genome assembly with spades. Okay, so this can be done after you have done your trimming to remove low quality weeds and etc. So the same approach, you just call spades. Let me just show you. You just call spades, and this time you specify your option. Let's say -1, that'll be read 1. And then -2, that'll be what? Read 2. And then you add your output directory, which is -o, and then etc. So you can do this with Singularity and then do your genome assembly. But this is something that I'm going to cover in an entirely separate video. Okay, so that's what you need to take note of. So for now, that's what I have. So this is a nutshell of how you can use Singularity to install bioinformatics tools via the definition file. So in future tutorials, I'll be talking about the other approach that you can use. So there's an approach to where you don't need to install. You can just download the container that someone has already built and then use that to run your analysis. So these are things we are going to look at in subsequent videos. And so I want you to come back later and then check more tutorials I'll be making on Singularity for bioinformatics. So that'll be all for today, and I'll see you in the next session.